Okay, let's go ahead and take a look at the last problem in this session. This problem is asking us to find V of C at 3 seconds. So V of C up here to the top right, left actually. And this looks kind of scary just because it's a big circuit, but let's take a look at what's actually happening here. We see that here we have a closed switch, but at time 0, we throw it open. And when we throw it open, we are going to close this here. Sorry, open it, and then we're going to have our switch like that. So now this creates an open terminal where no current can flow down through it. Okay, so now that we have that figured out, what we can do is we can come in here and say that we know that the current is unknown. So since the current is not known, that's another issue that we have with this problem. But since this is open and we know that our capacitor here had been charging up when it was closed, we have to assume that before we threw the switch open that it had been charging for infinity for a really long time. Okay, so it's charged up to its max. And what this gives us is we know that here since this was charged up to max, we had our two terminals, and our voltage, since these two branches are in parallel with each other, are going to be the same. But something to note is we do have this resistance here. Luckily, though, it's not going to affect the voltage because no current can flow down this branch whenever we have this closed wire like that. So initially, it's like this. No current can flow down those sides. So the voltage here is equal to the voltage there. Because there's no current flowing through this resistor can't absorb any voltage. So therefore, those 2 points are the same, which if we look at our circuit here, we have a battery on this branch and that's it. So there's a voltage gain. So the voltage gain from this branch is going to be equivalent to the voltage across those two open terminals. So I say all that to say C initial voltage is equal to 12 volts. Now, once we go and open this back up like this, now there's no more current flowing from this branch, and we create, sorry, let me fix this. Bam, bam. Okay. Now, the only thing that is going to be supplying voltage to the circuit is going to be the capacitance. Because it's got voltage stored up in it, it's not going to send some out through the rest of the circuit, like such. So in a sense, you can almost think of it like this capacitance is acting like a battery pumping voltage into the system. But it's not constant, it's going to run out. So we know that V of C at infinity is equal to 0 volts. So for our discharging equation, because it's stored up and then it's dispelling all of its voltage, V of C at a time is equal to V of C infinity plus V of C 0 minus V of C at infinity e to the minus t over tau. Okay, and looking through here, what else do we know? We know that time is equal to 3 seconds. So let's go through here and mark off what we know. So we know that, we know that, we know that, we know that. The only thing we don't know is tau. So now we got to go find tau. So tau is equal to RC, which is our equivalent C. So what we're going to do is treat this entire circuit like it's a battery, or like it's the entire circuit as if there's only one battery, which is the capacitance. And since this branch is not doing anything in the circuit, you can effectively go ahead and ignore it. And now we can just come in here and work that way towards the capacitance that's acting like a battery and find out what the R equivalent is going to be. So we see that here, these are going to be in series, and then these will be in parallel. So this will be series 1, parallel 1. And then after, the entire branch is going to be in series. So I'll call that series 2. And if we write those out, we'll get our series 1 will be 3 plus 1 is equal to 4. Our parallel 1 will be 4 times 2 over 4 plus 2. This will give us 1.33. And our series 3 will be 1.33 plus 3 plus 2, which will give us 6.33 ohms, which is our R equivalent. So now we have our equivalent. Do we have the capacitance value? We do. Sometimes they place it in a weird location at the bottom. Just be looking out for it. So tau is going to be equal to our equivalent C. So this will be 6.33 ohms times 1.57.9, 157.9 millifarads, which will give us a value of 0.9995, which is approximately 1. So now we know our tau is equal to 1. So now all that's left is we have to come in here and plug everything that we know in. So V of C at 3 seconds is going to be equal to V of C infinity 0 plus V of C initial 12 minus V of C infinity 0 e to the minus 3 seconds divided by 1 second. So V of C at 3 seconds will be equal to 12e to the minus 3, which will equal to 0.597 volts. So there is your capacitance voltage at 3 seconds. So there we go. So yeah, just knowing that the switch operations and the capacitance values at the initial and the final will really help you solve these problems.